Okay, welcome back. This is Module 2. Module 2 is an extension of Module 1, so if you haven't watched Module 1, you should do so. And in this module, we're going to talk about control points and how control points can be used to increase the spatial accuracy of your cadastral data. In Module 1, we did some very basic digitizing, some very basic COGO with respect to this water easement here, and this is the result we got. However, it is not in the right spot. So the image on the left is the easement as we drew it in Module 1. The image on the right is a better representation of the location of the easement. And we got it there by using control points and bearing adjustments. A control point is a coordinate location for a physical feature that can be identified on the ground. And essentially, control points are the foundation on which your cadastral is built. Now think of it like this, simply, how do you know where your parcel lines are supposed to go unless you have something on the ground, a point on the ground to associate them with? And when you get deeper into cadastral mapping and begin using the fabric and such, you're going to be introduced to a concept called least squares adjustments. That is, ideally, in a perfect world, you would have control points for every single one of your corners. But realistically, that's not going to happen. So the next best thing is to use a statistical process called least squares adjustments to attempt to guess where your parcel corner should go based on control points that you do know. So the more control points you have, the better, but if you don't have control points, you use least square adjustments. Here at Mono County, anytime we're working on a project, be it something for the assessor's office or something for public works, the workflow basically goes like this. We start with the control points. So what you're looking at here, this is a series of control points. Once we have the control points in, we can begin associating other elements with those control points. In this case, we're looking at the PLSSS lines. We could also add other layers. This is a digital elevation model. And here are some contours. And, well, you can continue to add layers. So what you're looking at here, you have your control points, followed by the PLSS data, some digital elevation model data, contours, digital surface model, aerial imagery, 3D model, parcels, right-of-way, street center lines, so on and so forth. You can continue to add layers here. The important thing is that all these layers are associated with those original control points. Now let's get back to our original problem here. The problem being that our easement that we drew in Module 1 is not located in the vicinity of where it's supposed to be. So we need to get it from the image on the left, we need to get that looking like the image on the right. And to do that, we're going to use bearing adjustments and control point adjustments. And in this module, we're only talking about the control point adjustments. The very first thing we're going to do is look for control points. Now going back to what we talked about in Module 1, we need to do some records research. So using the methods identified in Module 1, we're going to find some records, and one of those methods is by looking through the tax parcels with owners data set. And if we do that, if we highlight the parcels in question, we find that there's 6 document numbers associated with these parcels that we can pull and look for corner records and such. Of course, another good source of records is the parcel map. And if you look at the parcel map here, you see there's 5 records identified. We're going to pull those. And another source of record is the parcel viewer. So we click on this parcel here, and voila, we find another record we could pull. And voila! After we pull all of our records, we find this one. This is an awesome record. It gives us a lot of information that helps explain our easement. I mean, if you look at it, you'll see that it actually has corner monuments. It has our easement digitized on there, and it references the document number. However, it does not give any bearings and distances related to the easement, so that won't help us in that respect. But we do have a monument. To be specific, it says that the whoever created this document found a 1.5 inch iron pipe that was stamped RCE 10467 per map book 2110, and it is the east 1/16th center of section 34. That's all good stuff, and we're going to use that. Now, the federal government has very specific naming conventions when it comes to naming the interior portions of their section. So the center of the section in question, the east 16th center of the section in question, happens to be right there. So the east 1/16th center point also happens to be the northeast corner of the west half of the southwest corner of section 34. So this is the original point that we were starting our traverse from back in module 1. You'll notice they have two different names. One of them is the federal government's name. The other is what this particular surveyor decided to call it. Two names for the same point. What we're going to do next is we're going to go out to the field with our GPS unit, and we are going to attempt to locate this particular monument. And what we're looking for is a 1.5 inch iron pipe that has a tag on the top that's stamped RCE 10467. And there it is. There's the monument in question. So the next part is to take our GPS and get the coordinates of this monument. So for module 1, we used a PLSS shapefile to determine our starting point for our traverse. And that is where the blue and yellow line there intersect. However, after getting our GPS coordinate and dropping it into the map, we could see that our original starting point is quite a distance from our GPS pointer. That is, we weren't starting from the right spot. The actual point we should have been starting from was that green triangle there. So now we've adjusted our starting point, and we're going to get a better idea of where our easement lies by beginning our traverse from our GPS point as opposed to this PLSS shapefile. Here we have before and after. The easement on the bottom is the first one we drew based on the PLSS shapefiles. The easement on the top is the one we drew based off of our GPS point. And here's how you input a GPS point into GIS. You simply create a point shapefile, right click, and you'll see the absolute XY option pop up. You then input your coordinates into the absolute XY box there. And for reference, the X axis is also your line of longitude. It's also your easting. Your Y axis is your line of latitude. It's also your northing, depending on what type of coordinate system you're using. So once you input the coordinates, your point will pop up on the map. And when I went out to the field, I didn't just find one monument. I actually found two monuments associated with this parcel that are identified here on the map. And with those two monuments, I have a very good idea of where that property line is located. And then I can move on to the next step. When I went out to the field to look for the property corners, I actually found two monuments, and I GPS both of them. And that enabled me to recreate this parcel boundary here. And you don't need to do that for this lesson, but we'll use it as a visualization, as you will see on the next slide. Here is the easement that we just drew in this lesson relative to the parcel lines. and we could see that, well, the easement fits nicely within the parcel lines, almost. It's skewed off a little bit to the east. And that's because we have some issues with the bearings that still need to be dealt with. So if you move on to Module 3, we'll talk about bearing adjustments and how to get this easement to fit nicely within these parcel lines. All right, see you on the next one.